Hello, my fellow YouTubers. Beside working on this Walter Russell / Bedini setup, it's time to weaponize Leedskalnin. And what I mean by weaponize is we got these 1-inch square magnets. I got them facing out how the same pole would be what it should be. So if this is south, it goes to a dipole into this part of the magnet's the north, and then this part's the south. So what we are doing now is we are amplifying the magnetic field of this whole wheel. So what I'm going to do is I can't get 3 magnets in here because when you take this magnet and push it up to here, it makes this one flip over. So we'll just go from top to bottom. So that means there's going to be a strong north here, north here, north in the center, but it's, there's something else going on there. And then there's a strong south here and south there. And there's south in the middle too, but it's crazy. I just had these two stick together. I'm going to have to figure out, I use my big pipe wrench to pull them apart, but yeah. Crazy thing is the strength of it. Oh my, yeah. That's like coming off with one hand. I don't want to hurt myself. So yeah, the strength now is gorilla. So we're gonna call a Leedskalnin wheel the gorilla wheel. So what I'm going to do is put these all the way around. And now the strength, it still remains a universal, meaning that there's a U-shaped or V-shaped magnet. And the ends of the magnets still are the poles that they should be. So everything will be north, south, north, south, north, south, all the way around. But we really amplified the magnetic field. I think this will help that Ed didn't have this availability in his day, and this will help me sort of go more into the workings of Ed and his writings, and his philosophies will dig deeper there. But right now, Walter Russell has got my attention. First time Walter Russell, beside the cone shaped Tesla coil that he worked on, Walter Russell now brings in a whole new chapter. So excited, super excited, and super excited here because this expansion of the dipole is what I'm going to do is come off of this horizontal dipole of this vortexian. So this would be the big wide center, and then it vortexes down to a funnel, okay, on both sides. So you have a double vortex. A Russellian vortex, I'm going to call it. And we're going to come off of that with a dipole that's going to be out here on this table. But what we're going to do is we're going to have all the meters hooked up, and the plan is, this experiment that we're going to do is going to be, I am going to build a magnetic diode. And that diode will be hooked to a LED. And when I take that LED, and we'll look at power in, okay, and when we take the electromagnetic diode and put it in the middle of the dipole of this. So this is north, everything is south here, and this is north facing out. So that means that the next dipole from this will be south, okay? So this is north, this is south. So that means if I put a dipole out here, that becomes south, and we'll have to test it on its strength from here out to, we'll see where a LED lights up. Okay, we'll use that as a junction. And wherever it stops, we'll put the conductor there, so we know that this and the conductor on the outside with the LED is lit. Okay, and then from the middle of that, we're going to put I'm going to build a electromagnetic diode, and that diode is going to be positioned, and we're going to show two ways of that diode. We're going to show it one way where it goes in and it interferes the dipole. And when it interferes the dipole, the light itself won't light, and it also shows more restriction as the lens effect will show up in between what we just put in here versus what wasn't in there. And you'll see more current being needed to run the wheel, okay? And then when we take the diode and flip it over, the LED will light up, which shows a load, and it'll show on the power in. Actually, it drops down in current. So we'll figure out what is driving that. And that's my key thing, because I've done this before. I never filmed it, but this wheel I've never done. So I've done it in another form of experimenting. But the fact that if you take that diode, electromagnetic diode, it's sort of like creating a virtual ground, but you're able to control the virtual ground in a different way. You're not winding the coil one way or the other like we do to make dipoles, but you're actually using the material itself to be the transition. And that transition would be the fact that it still draws energy, but it doesn't reflect back on what created it. It's sort of a spring off. It's a dipole off, spring off, without a load on the initial start. So interesting stuff. I think this kind of falls in the realm of energy you can pull from some other place. Okay, we'll call it that. You guys have a good day. Leave your comments. Leave your comments. You know, this is touching base with the next level of the onion, and it makes so much sense, because if what I really see is there's a stretching in the ether, and it's based off a dilation of dipoles, and that dilation itself would be able to stretch and open up the ether to where there was like a opening where you can be to the other side. And once you get to the other side, the door shuts down and you're there. And then you'd have to turn around and come back somehow, and it has to open up, and you go back in, and then you're in that dimension. It's dimensional is what it is. And I see it. It's there. It's not like the ether is anything other than a response back. But in order to have one, you have to have the other. Leave it there. Leave your comments. Peace out, bro hams. 9 minutes of joy.